everyone, welcome to Friday's lesson, even though it is technically Sunday night. Sorry for the delay in the video, but let's get stuck into it. Alright, the last part of this topic is looking at transition matrices. So transition matrices are basically the way we describe transitions between two different states. So we're basically looking at if something is more or less likely to happen depending on data that we have from previous events. We use matrix multiplication for this, so we will be multiplying two different matrices. We also use this to sort of determine if there's any trends in the data that we're looking at, and then we can make predictions, hopefully. Sort of makes sense. I find the best way to explain this is actually to do a couple of problems. So let's get started. There are two parts to a transition matrix: the transition matrix and the state matrix. And we will basically what we will be doing is we'll be multiplying them together. But let's have a look at the example. Alright, Jess has noticed that some people at her work keep leaving the fridge door partly open. She estimates that the door is currently left open 10% of the time, and she suspects the problem is getting worse. She has noticed that the state in which a person leaves the fridge depends on the state in which they found it. So, there are two options for the state of the fridge. The fridge is either open or closed. There's nothing in between. So, this information will be in the state matrix, and we had some information in this statement up here, so we can see that it's left open 10% of the time. So we can create a matrix about the state of the fridge. Sorry, that's my dog. Shh. Shh. So you can see the state of the fridge, so 10% of the time it's open, 90% of the time it's closed. I can then redo that as a matrix, so you can see that I've changed the, decimals, percentages to decimals, and now I have my matrix. I've called it S because we call this our state or our initial state matrix. Alright, then we get given some more information. So, 30% of people will leave the fridge open if they find it open, 70% of people will close the fridge if they find it open, 5% of people will leave the door open if they find it closed, and 95% of people will close the fridge if they find it closed. So, we can now put this information into a table like I had the other one, and you can see here, so this is the current state and this is what happens in the future. And I can make this one as a matrix, and you can see here I've changed it to decimals, so this is my transition matrix, and that's why I label it T. So S is the state matrix. It shows the current state of the fridge, 10% of the time it's open, 90% of the time it's closed. T is the transition matrix. It explains how the fridge system will change each time someone visits. Alright, what we want to do now is evaluate or solve S times T and determine the likelihood of the fridge being left open after the next visitor. So I've got S here, I've got T here, and I'm going to multiply them together. This is what I put S in as mat A in my calculator and T in as mat B. So if we have a look here, you can see that I've got them both saved. There's my transition, and now I'm going to go mat A multiplied by mat B, and this is my matrix. So this is my answers, and if I want to interpret this, I want to know the likelihood of it being left open, so I'm really looking at this bit of information here. and I want to change it back to a percentage, so it would mean that 7.5%, there's a 7.5% chance that the next visitor will leave the fridge open. Then it wants me to evaluate ST, so that was my results from just before, this one here, and they want me to multiply it by my transition matrix again. So the first thing I'm going to do is save this one as mat C, so I don't need to put it all back in again. So I've got that saved. Now I can do mat C times by mat B to get my new answer. So now I have the chance of it being open is 6.8%, or probably 6.9%, and the chance of it being closed is 93.1%. So if I'm interpreting these results, it means after the second visitor, there is a 6.9% chance of the fridge being open and a 93.1% chance of the fridge being closed. Then it wants me to evaluate S times T to the power of 10. So this is really asking me, is every time we multiply it by the transition matrix, that is effectively a new person coming to the fridge. So this is saying that if 10 people, so the 10th visitor comes to the fridge, what is the chance of it being open and what is the chance of it being closed? So we're going to evaluate it, and then it says predict the proportion of the time the fridge will be left open in the long term. Is Jess's concern that the problem is getting worse justified? Alright, so we're going to do S times T to the power of 10. Again, this will go in my graphics calculator just like it did in the question before. The only difference is I'm going to have to the power of 10. Now, this is my answer that I got, and if I'm interpreting it, it means that in the long term, the door is going to be left open 6.6% of the time and closed 93.3% of the time. Now, if we compare it back to the current state, so just worked out that currently it was being open 10% of the time, so the issue actually isn't getting worse, it's getting better. So her concern is actually not justified. So that is how you do a question on transition matrices. One more little tip before I give you some questions. So a transition matrix is used to model how systems change in time. The matrix is denoted by T. Now, your rows always need to equal 1. So, if it's not adding up to 1, you've made an error somewhere. So, yeah. Can you please do question 1, 2 and 3, exercise 9D.1, and you can find all this information on our OneNote. Good luck. Bye.